Okay, all right. So, do you understand this example? Okay, you did. Okay, let's move on. This one, that would be easy. Prove they are congruent. Yep, easy. How about this one? That's easy. Alright, so you only have to go through one thing. Oh, these will have no formulas. You just do it. So you just go, surface area for that one will be, volume will just be 5 times 5 times 5, right? Just 5 cubed. That's why it's called cube for a reason. And this is 125. That's where the word cube comes from. Comes from the word cube. 5 cube means 5 times 5 times 5 from a cube. Now, how about surface area? All faces are the same. What do? 6 times area of one face. 6 times 25 is 150. Get the idea? That's square, that's cubic centimeters. Yeah. So no formula for this. You just do it. Get it? Whereas volume for that, you just go 8 times 15 times 12. Right? And the surface area, you just go 2 lots of 8, 15, 15, 12. You just do all possible combination. Get it? Yeah. So if you want a general formula, I could give you, if that's X, that's Y, that's, actually, let's use ABC better. So ABC is just go to AB plus BC plus CA. And the volume is ABC. All right, so that's the formula, if you want to use it. All right, let's continue. And then there's a hard question at the end, which you said was hard, so let's go through this as well. All right, so it's very important that you know how it works because it could be in the exam. These formulas are not given in the exam. There's no formula sheet for this, so you have to remember them. All right, let's find the surface area of a cone with a height twice the radius in terms of r. All right, so height twice the radius, so what would the height be if the radius is r? 2r. So the formula is surface area is, what's the formula? Pi r squared, that's the area of the base, plus 2 pi rl. Pi rl, sorry, pi rl. Pi rl. And then what do we do? Is that what I wrote? Yep. 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 Okay. Pi r squared plus pi rl. So we're going to, that's the height. Oh, I get it. Okay. Now we need to get the slant height. How do I get the slant height? We use Pythagoras. So we go L squared equal to 2r squared plus r squared. Yeah. And you get, what's 2r squared? Becomes 4r squared. Get it? So you have to square the 2 as well, which is 5r squared. So how do you find L? You have to square root it. So let's go through this. So L equal to square root of 5r squared, which is just root 5r. And that's what you're going to substitute. So now we've got the pi r squared, got the pi rl, which is root 5r. And if you simplify, you get pi r squared plus pi root 5r squared. That's a plus. Right? R times r is r squared. And then you can factorize the pi r squared out, which you can write like this. Oops, root 5. Is that what you were told? Yeah. Hopefully, yep. Does that make sense or it still doesn't make sense? Okay, good. All right, so note this down. And then we'll do revision today. So we've got how many pages? 4 pages of revision, which we'll do very quickly because they're so known to you. Okay, 4-page of revision, and then we'll do revision for the test. And yeah. All right, let's go through. Yeah? Say again. What's new thing? Functions. Yep. So I've got it all planned for you. Today we'll do revision, chapter 4 review. On Friday we'll do the functions, 5.1, 5.2. We'll be tested up to 5.2, and then we'll do 2 weeks of revision.
So we get tested on the Tuesday.
Yeah. Part of geometry, part of chapter 4. No, just whatever on the notice. Oh, I'll give it today. There you go. Okay. All right, good. Thanks for reminding me. Let's move on to the next page. Okay, so what do we have? All right, let's look at this stuff. That's very easy to do. Angles in a right angle. That's a 90 degree. And angles on a straight line. I think what I'm meant to do is you draw an angle here, x, that's a y, they add up to 180. And the other one, these add up to 90. And then you also have angles at a point, means that they have more than one, more than two. So you got A, B, C, they add up to 360. So you have an angle for 90, one angle for 180, one angle to 360. But there's no name for 270. Or you can call it reflex. Vertically opposite, so you get this. They draw a cross and the two angles are equal. A equal to B. Okay, good. Any question? All right. What do complementary angle add up to? 90 degrees. And supplementary, yeah, just remember S dot rhymes with the same letter as the straight. That's why it's 180. Be careful. These you can say two angles are supplementary, but you can't say three angles are supplementary. So these words only apply to two numbers, not three. Okay, good. So now we look at parallel lines. If the lines are parallel, we can see there are three different types of angle. There's the corresponding angles are equal. Don't know why they're dotted. Why are they dotted? Oh, okay, looks dotted. Yeah, because it's on a slant. Okay, all right. So we're going to say corresponding angles are equal. Alternate angles are equal. And co-interior angles are, it's longer, it's supplementary. Because there are two angles, I could use the word supplementary, like this. So A and B, A plus B is 180. Whereas this one, A and B, they are both equal to each other. All right, these are the three angles. Now, how do I prove lines are parallel? We just have to prove these three properties exist. So to prove lines are parallel, we just have to prove the corresponding angles are equal. Need more space. Okay. Or the alternate angles are equal. And what's it called? Supplementary. Which one are supplementary? Co-interior. Okay. Co-interior angles are supplementary. And there's a little example for you to try. Are these parallel? How do we know? Yep. Yeah, not because it's co-interior. You have to check the co-interior adds up to 180. So if you do angle E plus angle F, which is equal to 78 plus 102, which is 180. So you say, therefore, ADB is parallel to CD because the co-interior angles are supplementary. Co-interior angles are supplementary. Done. All right, good. There's more. There's 4 more pages. We're still not even 1 page through yet. Okay. Triangles. What do we know about triangle? Angle sum is 180. Very good. So ABC again, A plus B plus C is 180. Exterior angle is equal to what? No, two interior opposite angles. Opposite. So that's an important one. Opposite angles. That's a good theorem to use. It saves you a lot of time. So if I draw exterior angle, just extend this line. That's A. That's B. This exterior angle is A plus B. And we'll call this the exterior angle. Exterior. Because it's on the outside. And the two interior is these two. These are the two interiors. Opposite to the exterior angle. Alright, so we looked at parallel lines, we looked at types of angles, we also looked at triangles. The next thing is look at different types of triangles and look at things. Okay, so in this topic we'll study a lot of triangles. We'll also study a bit of quadrilateral as well. So they are the building blocks of any shape. That's why triangle, we need to spend a lot of time on it. Okay, there are three different main types. There are the equilateral. And what do we know about equilateral? All angles 360, all angles 60, all sides are equal. Okay, so they're all equal here. 1, 2, 3, and all sides are equal. Like that. Isosceles triangle. Two sides and two angles are equal. Angles. So like this, the two base angles are equal and the two sides are equal. Okay. And we have a right angle triangle, which just have right angle there. That's it. So these are the three main ones that you may be using in the test. The next question is, how do we prove a triangle equilateral? How do we prove it? There are two ways. Either prove three sides equal, or also another way, three angles equals to equal to 60 each. So you either prove all angles 60 or prove all three sides equal. Okay, how about the next one? Isosceles. How do I prove isosceles? It is isosceles. There are two ways. Again, two sides equal. What's another way? Two angles equal. All right, good. So we need to know two things. One is, given it's equilateral, we'll know these properties. And the other one is, you have to prove it's equilateral, where you have to prove these properties exist. So there's two different types of questions. And lastly, how do I prove something is a right angle triangle? Well, how do you know it's going to be a right angle? How do you know it's going to be 90 if it's not labeled there? So what you do is, you use sides. You measure the length of all the sides, and then what do? You check, yes, the Pythagoras theorem works. I don't know why I draw two. I forgot what I do with it. Anyway, so I forgot to do that. So if it's a right angle triangle, there is an important property called Pythagoras theorem. Right? And you can also use Pythagoras theorem to prove it's a right angle triangle. So note the difference between them. Yeah, I can't believe I forgot why there's two. Anyway. Okay, let's move on. Polygon. Next thing is, we need to look at parts of triangle. What's an apex? The top bit. Yep, apex, that's the top bit. Median is the line joining to the middle. Altitude is the height. Note the difference between median and altitude. One's a right angle to the base. One's connecting to the middle of the base. Obviously, they're usually not the same. But when would they be the same? Equilateral, where the median and the altitude are equal. So if it's an equilateral or isosceles, the median equals to the altitude. Median equals to the altitude. So that's chapter review. Okay, scaling triangle. Yeah, so the reason why I draw here, because if I draw a altitude and the median, they will not overlap each other, right? Whereas if it's isosceles equilateral, they will overlap each other, right? Both median and altitude are the same, which is a useful fact to know. All right, so we've got these stuff, and what do? Polygons. Polygons are pretty easy. The only formula you given in the formula sheet is the polygon, which is angle sum of the triangle. Angle sum of a polygon, which I will show you over here. So on your formula sheet, It's very slow. Okay, good. You've done this. Now there's a polygon. That's all. And then the trigonometry. I think that's what we've done so far up to here. So during the exam, you only have to look at this part. Oh, there's a quadratic formula, which is on this page. Quadratic formula. Okay, all right. That's the only thing you can use during the exam. Everything else you don't need to know yet. Okay, let's move on to the next bit. Polygon. Angle sum of polygon, yes, it's on the formula sheet. 180 and minus 2. And minus 2. Sum of the exterior angle is 360. Doesn't matter how many sides you have, it's always 360. Sum of an interior angle and its adjacent angle is equals to... Alright, what does that mean? So if I draw a polygon like this, if I extend the side, the exterior angle and the interior angle equals to 180. So adds up to 180, the sum. So that's the interior, that's the exterior. So the one adjacent to this is adjacent to it, next to it. The exterior and the interior adds up to 180 for a polygon. And for a regular polygon, have all something equal. Sides and angle. Yep, for a regular polygon, all sides and all angles are equal. Okay, done. All right, so we looked at all the properties, all the words we know about triangles and polygons. Next, we're going to look at congruent triangles, which is another very important aspect, which you will use a lot in the exam. There's the 3-4 test. Side, side, side means if you can prove all three sides are equal, they are congruent. Oh, don't know why. Oh no, it's supposed to be like this. I forgot to change the order. I'll update in future edition. Okay. Right, SAS means two sides are equal and the angle in between are equal. Okay. Anyway, okay. AAS means two angles are equal and one side is equal. And finally, RHS is they both has to be right angle, but then the sides are equal, and it has to involve the hypotenuse. Hypotenuse. Let's get a highlighter. So note that it has to use the hypotenuse. If it doesn't have the hypotenuse, it's not RHS. For example, if you got a triangle like this, what do we call this? Yeah, even though it's a right angle, because it doesn't involve the hypotenuse. So once you involve the hypotenuse, it's only when that is called RHS, okay? All right, what's the next thing? This thing means what? Means congruent. Triangle ABC is congruent to triangle DEF. All right, okay, done. Very good. We did 2 pages already. 2 more pages. Once you do congruent, there's the similarity. Let's look at briefly what the properties of similarity. 2 figures are similar if they have the same shape but different sizes or different size. Okay, so one will be bigger than the other. 2 figures are similar if one can be enlarged to be congruent to the other one. 2 shapes are similar if the matching angles are equal. Note that for similar triangle, the angles are equal, but the sides are not equal, but in the same ratio or in the same proportion. Or you can write ratio. Okay, good. And there's the 4 tests. Proportion. Proportion. Okay, proportion. Proportion. I just realized it's very symmetrical. See, ROPOR, right? It's, what do we call this? Palindrome. Yeah, only this part. Yeah, palindrome. Okay, good. All right. Race car. Does it work? Race car. Ah, yeah, race car. Very good. All right. Okay, all right, that's good. All right, let's move on to similarity test. Now, as you can see, I left more space because you can't use this abbreviation. What's the first one? You say all three sides are in proportion. No, all three sides are in proportion. So, for example, I'll give you an example. So you got, say, this is 1, this is 2, this is 2, this is, say, 4. No, it wouldn't work. Would it work? No, it doesn't work. Yeah. What? Let me choose something like 3, 4, 5, 6. That will work. 6, 10, 8. Okay, so all three sides in proportion. What's another thing? Equiangular. Yeah, this is a popular one. Angle, equiangular. All three angles are the same. You just need to prove two angles. Only need to prove two angles are equal. Okay, good. Two angles. All right, what's the next thing? The other two are a bit long, so I'll leave that a bit late. Okay, what's the other one? You got angles are the same, the included angle, and two sides in proportion. So we've got 3 and 6, and 4 and 8, right? So we say two sides are in proportion. Now I know how to spell because it's Pannenberg. Proportion. This part. Okay, that helps me. This part. Yeah, proportion. Okay, two sides are in proportion and the included angle. Very important, use the word included angles are equal. Like that. And the last test, which really rarely gets used, but you still need to know, is they're both right angle and the sides are in proportion and the hypotenuse are in proportion. Okay? So you can just write it. Let me try to write it. So two sides and one side and two. One side and the hypotenuse of one right-angled triangle is proportional. That's the longest one. To one side and the hypotenuse. By the time I finish the exam, finished already. I'm checking. All right, and the hypotenuse of the other right angle.
Did you just say one side of the hypotenuse of the right angle triangle is proportional to another? Do you have to say it twice?
Maybe. Just write it.
That's really long.
I know.
That's
why they don't really ask that. They don't really ask that.
Don't put it in there.
Oh yeah. Okay.
You're dodgy. You put it in. Can you do our name?
Yeah. Okay. Maybe. All right. What does this mean? Similar to. Okay. Okay.
And then our class will do so well.
Okay. All right. Let's move on. Let's move on. Okay. Ratio of intercepts. These are called intercepts. Intercepts. These are called intercepts. All right, let's write down AB over BC is equal to DE over EF. Now, this can also be used on these stuff with the intercepts, like this. Also work here as well. So you can do 6.2 over 4. Actually, you start like this. And to solve this, you start with the polynomial. You start with m over 5.3 equals to 4.7 over 6.2, which you can proceed to solve for m. Okay? However, if you were to find p, you have to use similar triangle. If you were to find p, you have to use similar triangle. It doesn't work with this theorem. It only works on intercept. Now, what's the reason you give in the exam? You just say ratio of intercepts of parallel lines. Okay, so that's the reason you write in the exam. This is the reason. So make sure you give the right reason. All right, one more page, then we're done. All right, so this summary page will be useful for you to study for your test because it has a summary of everything. We just got one more page. We're going to move on. Did you write it? Show me. Put it up. All right, let's move on. Okay. Okay, let's move on. Okay, property of quadrilateral. So as you can see, this topic mostly about triangles, and the last page is the quadrilateral. All right, angle sum of quadrilateral. What's the angle sum? 360. What's a trapezium? One pair of parallel sides. Just one pair. Okay. What's a kite? Adjacent sides equal. Yep, so adjacent, so like this. So these two are adjacent, they're equal. They're next to each other. And then the other one's also equal. These two are adjacent. So that's a kite. All right, then we have to look at parallelogram. What are the properties of parallelogram? There are 4. Which 4 can you name? Say again? Yep. Opposite sides parallel. Yep. No, they are, but that's not the main property. Angles, opposite angles are parallel. Yep. What else? Oh, equal. Sorry, equal. Okay. Yeah. Yeah, because of all your distraction. Okay. Opposite. What else are opposite? Opposite sides are what? Equal. And we'll go one more. So there's 3 opposite. One of them are different. What they are? Diagonals are not equal. Yep. Each other.
So you don't need the order.
Bisect. Yep, you're right. Bisect each other. Okay, good. Next, we're going to look at rectangles. Rectangle will have all 4 above plus 2 extra ones. They are all angles 90 degrees and diagonals are equal. So only for a rectangle the diagonals are equal, not for parallelogram. And then we got rhombus, which is all 4 above plus 3 extra. They are all sides equal. And then the diagonals are perpendicular. And one more about diagonals. The diagonals also bisect vertex. No, it can be rhombus. Diamond, right? Just right there. Yep, I will. Like this.
The square on the side.
No, but you can make it thinner. That's not square now, right?
But it's still the same on the side.
Yeah, but that's not square. Like, how can a square has to be right? 90 degrees, whereas this one's not 90.
Oh, okay, I get it.
Squish, yeah, got squished. Okay.
Honestly, Brandon, do you not know the difference between square and octopus? So dumb.
Alright, let's continue. A square has all of above. No, but you can see that because it has all of above, we know that it has to be 45 here because it bisects the vertex angle. Yeah. Okay, now we have to write down the test for parallelogram.
Christina, please don't explain questions to you.
Anytime.
Okay, let's write down the test. Let's look at the test and we'll finish. Test for parallelogram. There's 5. Prove.
Did we not just write it down?
No, these are properties.
Is this properties?
These are properties. I know these are properties. Now we're doing the test.
What is it the test you're testing for the properties?
Yeah, testing has 4 properties. There's actually 1 extra, which I'll show you. Opposite sides,
Sir, you're thinking of the game.
2 pairs of opposite sides are equal. Pairs, right? Opposite sides equal. Or 2 pairs of opposite sides parallel. So it's really proving the property has these properties. Or 2 pairs of opposite angles are equal. Okay. No, you look like an L. You can cause confusion in the exam. You may lose mark. That's my recommendation. Yep, you can write. No, you can say triangle ABC, but you don't say triangle is equilateral. You get what I mean? Because that can be confused with something else. But it only works in a thing.
If you get confused with that,
That's my opinion.
If you get
All right.
confused with that, I think you shouldn't be confused.
No, I'm just saying that someone else who marked the exam may get confused.
Not you. I'm right. I'm starting the HSC, not knowing what a triangle is.
All right.
Like, you shouldn't be.
All right, 2 more tests.
You're not playing the game.
Diagonals bisect each other. And what else are there? One pair of sides, both equal and parallel. Get the idea? So there are actually 5, not 4 tests. The 5th test is a combination of sides equal and parallel, right? Except that you only prove 1 pair, whereas the other one you prove 2 pairs of sides equal or 2 pairs of sides parallel. But if you prove 1 pair, it has to both equal and parallel. Get the idea? That could be, yep.
Okay, so we don't have to know the
Also, you either do both sides are equal, you do one side of one.
Yeah, 1 pair, just have to be the same pair. Has to be the same pair though. Yep. All right. How about, yep.
We don't have to know the properties. We don't have to know the
Well, sort of they are the same.
Yeah, so that's what was the point of it?
What
So
the,
you learn it all.
well, see, let me show you some question. Remember we did that before about testing properties?
Yeah.
So when we did these questions, like these ones, right?
Yeah.
Where's this one? Yeah, this page.
Yeah.
We prove it's a parallelogram, so we have to prove that it has these properties.
Oh, okay.
Or if we know it's a parallelogram, then we can use it to find, so that's a parallelogram, we can use the fact that they bisect each other.
Yeah.
So get the idea? So sometimes given it's a parallelogram, to find the missing sides or angles,
Yeah.
or given some information about angles and sides, prove it's a parallelogram.
Yeah.
So two different things. Okay. All right, let's move on to one more. So now we have tests for parallelogram. There's also tests for rhombus. I don't know what they are, so you just go back to this page. I think I wrote them all down over here. On page, this page here, I forgot what page, let me tell you. Or you can also check the table of contents, that will tell you the page. So if you go to page 23, you'll find the test for rhombus. Let's write them down on the last page. Okay, page 23. I'll write down on the bottom, page 23. So let's write them down. So all sides are equal. And diagonals bisect at right angle. Or the diagonals bisect the vertex angle. Bisect, that's the longest to prove. Bisect each vertex angle. Like that. What else are there? Properties of a test for rectangle. All angles are equal to 90. Or diagonals are equal. And they also have to bisect each other and bisect each other. Done. And then finally a square, you just have to prove it is both rectangle and, you just have to prove all sides equal and one angle 90 degrees. What else are there? Or you can prove diagonals bisect each other at 90 degrees and diagonals are equal to each other. So basically proving that proving both the properties of rhombus and rectangle. Okay, all right, that's exhausting. All right, so we finished all this. So that's the end of geometry. You have to study and do a lot of questions. You will meet them again in the HS